Assalamualaikum warahmatullahi wabarakatuh. Welcome to my finally Project 1 presentation. My name is Amirul Hakimi bin Mohamad Maulana, and this project is supervised by IR Dr. Khairul Fikri bin Tamrin. I will carry on the topic, which is low-cost electrical resistance tomography for Ganoderma disease detection in oil palm. My presentation is based on the introduction to the disease and the method of detection, a bit literature view, methodology, and conclusion. First is on the introduction. Before we go further about the main discussion, we need to know a little bit on history of Ganoderma disease. In 1870s, British brought the oil palm tree to Southeast Asia, including Malaysia and Indonesia. It is originally coming from West Africa. Then, in 1931, the first case of Ganoderma disease in Malaysia was recorded, and it is detected by Thomson. Nowadays, due to spreadness of Ganoderma disease, many methods of detection has been introduced. Ganoderma disease indicates the presence of white rot fungus in oil palm trunk, and it was caused by a pathogen called Ganoderma zonatum. There are various types of species that live under Ganoderma families, including Trimeters, Pleurotus, Lentiporus, and Phenifora. According to research, this disease can give huge impact to economy, which will cause losses up to 45%. Detection method can be done either by destructive method or non-destructive method. Destructive method will destroy or change the sample after passing through the test, and it is mostly involved in mechanical properties testing, such as evaluating properties of material. Non-destructive method will not destroy or change the sample after passing through the test, and it will be implemented in this study. Electrical resistance tomography is one of non-destructive method. It is an approach that utilizes a resistance measurement from a set of arrangement of electrodes through any body to determine the subsurface properties of electrical resistivity. It is a technique for imaging any subsurface structure from the resistivity measurement. Electrical resistance tomography utilizes a direct current method for resistivity measurement. The problem is, most of the methods existed nowadays are expensive and time-consuming to be conducted. Plus, it requires professional and knowledgeable people to conduct due to high machinery and instrumentation. On the other hand, some equipment in ERT are expensive, including the transmitter, multiplexer, power supply, and receiver. Thus, the objective of this study are to propose a low-cost electrical resistance tomography for Ganoderma disease detection in oil palm trunk. Second one is to analyze the presence of Ganoderma disease by reconstructing an electrical resistant image by the aid of software. And the last one is to determine the efficiency of utilizing the low-cost ERT instrumentation on Ganoderma disease detection. Next will be on literature view. Non-destructive method can be classified into two types, which are contact and non-contact method. Contact method including mid-infrared spectroscopy, dielectric spectroscopy, interdigitated electrode, support vector machine, polyclonal antibodies, polymerase chain reaction, and ergosterol. Non-contact method including hyperspectral reflectance, nose system, spectroradiometer, ultrasonic wave, gamma ray, and laser scanning. I will introduce on nose system. It utilizes the usage of an artificial intelligent electronic appliance, which is Cyrannus 320. It is a sensor that can sense including the odor from the Ganoderma fruiting body by using artificial neural network ANN algorithm. It has an efficiency of 85%. Next is laser scanning. Laser scanning is an application of ground-based LiDAR technology, and it can be used for Ganoderma disease detection. It can detect the disease starting at 200 centimeter distance and up to 1.5 meter distance, and it has an accuracy of 86.67%. And chapter 3 will be the methodology that will be implemented to achieve the objective of this study. So this is the flow or steps on doing the experiment. It starts with the arrangement of electrode according to Wagner alpha array type, which will be explained in the following section. Before conduct the experiment, we need to calibrate one of the sample as an early precaution and preparation to determine the input parameters, such as circumference of all palm trees. Then, conduct a preliminary test by utilizing the input parameters to obtain the output parameters. Before ending the preliminary test, the reconstruction of two-dimensional tomograph image will be done by the aid of MATLAB software. Then, observe the result, either it is acceptable or not. If the result is unacceptable, the preliminary test needs to be repeated as to improvise any lacking issues. After satisfying the preliminary result, proceed with the actual experiment that involves in determining the output parameters through the three different levels of height, which are at 0 centimeter, 60 centimeter, and 120 centimeter. This is an explanation on Werner array principle. Werner array principle is a principle of electrode arrangement that applicable in ERT field. Resistivity reading in ERT depends on the electrode arrangement in terms of geometric factor K, which can cause the resistivity to be low or high. Each type of array are having different types of electrode arrangement. In this study, we are using Werner array alpha type. It indicates an equivalent distance between electrode with alpha units. This method provides a current flowing from A to B and causing a voltage difference between M and N. The resistance between electrode M and N and the geometric factor can be shown as in the formula below. In order to build a low-cost ERT instrumentation, we need to replace several equipment to make it low cost. First, usage of nails can be used instead of zinc, copper, or lead plate, and we will use 8 units of them. Second, rechargeable battery can be replaced with conventional power supply. And finally, the usage of multimeter can be used to read the current and voltage difference. So, this is the experimental setup for a low-cost electrical resistance tomography. The first 4 electrodes will be carried on during the process, and the next calibration will move to the next setup for electrode 2 to 5. The experiment goes until each resistivity between the electrodes has been obtained. And finally, the two-dimensional tomograph image reconstruction is based on parameters such as numbers of electrodes, distance between electrode, and resistivity are obtained from the experiment. And then we can obtain the 2D tomograph image reconstruction. This process can be done by implementing a set of coding that provided by the MATLAB and insert those parameters for two-dimensional tomograph image reconstruction. Thank you for your attention, and that's all from me. Thank you.